example 21, our last example. The ramp from one level to the next in a car park is 20 meters long and drops 4 meters, sorry. So it's a ramp from one level to the next. Okay, so we're going to have our higher level up here and our lower level down here somewhere. Well, it's going to be exactly 4 meters down there because it drops 4 meters. And here's our ramp. Let's draw a ramp. Could be going up if you're standing down here. Could be going down if you're standing up here. And it's 20 meters long. So we can label that 20 meters. And it drops 4 meters. So that means we know that this distance here, or this height, down to the bottom of the ramp. Let's just draw in this ground level line as well. So this is the lower level, that's the ground of the lower level. We know that this drop from this is the ground of the upper level as well. This is a ground up here. From this ground floor, from this, let's say this is level 1. From level 1 down to the ground floor, that's a drop of 4 meters. Okay, find the angle of depression of the ramp to the nearest degree. So this time they're asking us to find an angle. They've actually given us 2 sides and they're asking us to find an angle. And I am just going to put in my right angle here because I can see that I've created a right angle triangle. This is a vertical drop and this is the ground floor. So I know that's vertical and that's horizontal. I know this is going to be a right angle. And it wants us to find the angle of depression. So where's the angle of depression going to be? We just need to mark in that angle of depression so we know what we're trying to find. So an angle of depression means that we're looking down because it's an angle of depression. So we can't really be down here on this ground floor because there's nowhere to look. There's nothing to look at if we want to look lower from the ground floor. We need to look down. So that means we need to be positioned up here. If we're looking down along the ramp, because remember it says find the angle of depression of the ramp. So we're going to be looking down along the ramp. So we need to be positioned up here. This is going to be where we're starting. That's our starting point. That's where we're going to draw the horizontal and that's where we're going to draw our angle. And the reason we know that is because it's an angle of depression. So we have to be looking down. So we have to be up the top to look down. Okay, so an angle of depression always starts from the horizontal. So we need to make sure we know where our horizontal is. We're here. Our horizontal is just going to be this ground floor here, or this level 1 floor. So we're just drawing a horizontal line basically from our point. So this is going to be one of our lines that make up our angle. And we're looking down, okay? It's an angle of depression of the ramp. So we need to look down until we get to our ramp. So here's our ramp. This is our angle here, from the horizontal down to our ramp. So you can see that that creates an angle inside here. So this is the angle that we want to find. It says find the angle of depression to the nearest degree. So we don't actually know the value here, but we can label it with one of the pronumerals that we use to label unknown angles. So let's call it theta. And now, which triangle are we going to use? Which trigonometric ratio are we going to use? We've got information about the sides in this triangle here, but we don't have an angle in this triangle. We've actually got an angle over here in this triangle. And again, there's a couple of ways that we can create a triangle with all of our information in it, with our angle and our 2 sides. First of all, again, we can use alternate lines. We can recognize that alternate angles. We can recognize that these are 2 parallel lines. This is a horizontal line. This is another horizontal line, so they're parallel. And we've got a transversal cutting across our 2 parallel lines. So that means that alternate angles are going to be equal. So this here creates a Z shape. So it means that's an alternate angle, which means this is also going to be theta as well. And then we can use this triangle here. We've got 2 sides and an angle inside the triangle. Another way we can do it if we're not super comfortable with using alternate angles, is I can look at this and say, well, I could actually create a different triangle up here using this angle as one of my angles inside my triangle. This is a horizontal line. This is a horizontal line on the ground floor. And I know that the drop is 4 meters. So instead of drawing the drop here, I could have drawn the drop here. I know that this drop has to be 4 meters. And I know this is a horizontal line, this is a vertical line, so this is my right angle. And I've drawn another right angle triangle that I could use. Because now I've got this side, the hypotenuse of my new triangle. I've got this side, I've got another side of my triangle. And I've got my angle, which is now inside this triangle. So there's lots of ways you can do it, but basically you need to make sure that you're looking at angles inside your right angle triangle that you're going to use. All right, so let's use this original triangle down here. Are we going to use So, Ka, or Toa? So our given angle, our angle that we want to use is this one here. So which sides do we have in relation to this angle? Well, we've got the opposite side here. And we've got this 20 meter side here, which is the hypotenuse because it's opposite the right angle. So we've got opposite and hypotenuse. That means we need to use So. And So stands for sine of an angle is equal to opposite over hypotenuse. Now we just need to plug in our values. We don't have an angle, so we can leave that as theta. We don't know our value for our angle yet. That's our unknown. We know the opposite was 4, and we know the hypotenuse was 20. So we just need to solve for theta. That's our only unknown. That's good. We only want one unknown. And the way that we, remove this sine function so that we can isolate theta and get theta by itself is we need to use the inverse function of sine, which is inverse sine. So this is what it looks like on the calculator. And we need to take the inverse sine of both sides to keep the equation balanced. Okay, these two will just cancel out. That's why we did it. We wanted to get rid of the sine function. We're just left with theta, which is what we want. And then we've got this expression here, which we can just type into the calculator. So if we want to get the inverse sine, we just press Shift Sine. And we should end up with that little inverse sine. And then we need to take the inverse sine of 4 over 20. So we type in that fraction and we end up with theta is equal to 11.54 degrees. But the question did ask us to find it to the nearest degree. So because this is in decimal form, we can just use normal rounding up. 11.54, that's over 0.5, so we round up. So theta is equal to 12 degrees. We can also change it to degrees, minutes, and seconds using our degrees, minutes, seconds button. And you can see that our minutes, it's over 30 minutes, so it's over halfway, so you round up here as well, so it's 12 degrees.